Okay, so welcome back everyone. This is Akshay here, and let us continue our GFG POTD streak of day 306 upon 365, and our continuation with the linked list playlist, that is delete a node in the singly linked list, right? So the question says that we have been given a singly linked list and an integer x, delete x node from the singly linked list, right? So let's just see first of the input test cases. So let us assume that we have been given a list of nodes consisting 1, 3, and 4, and we need to delete the third node. So definitely this is the first head node is our first node, this is the second node, and this is the third node. So we need to get rid of this third node and we need to return the remaining list, right? So the remaining list would be nothing but 1 and 3. So that is what it's in the answer. So how we can do this question? So first method, that maybe we the first thing that maybe we need to get the size of the list. Yep, will that work? Right, the first thing or the first method or the first thing comes to the mind, maybe you can do with the get the size of the list. Then in here we can just check that if the size, let's say it is stored in the ith pointer, so if it is the given xth node that is to be deleted, if it's greater than equals to I, then definitely we do not have to do anything, right? So the node that is to be deleted is beyond the list, beyond the number of nodes we have, right? So we'll just say, in this case we'll just say that nothing is possible, just return null, right? That is said by the question, I guess. Your task is complete. That is the function returns the head of the. Okay. Okay. Great. And we need to handle some base cases. So for this thing, the what is the length of the list? It is 3, right? So that means we need to traverse. We need to traverse 3 times. Well, let's say if you're starting traverse from I equals to 0, then we need to traverse for x minus 2 times, right? 3 minus 2 will give you 1. So at this point of time, you will have 1, right? 0th. And then when you shift to the next point, your I will become 1, correct? And you need to grasp the hold of just the previous node, the node which you want to delete. You need to grasp the hold of just the previous node, so that you can just say that this, let's say I have a grasp of this node, and just say that pre dot next is equal to nothing but pre dot next, right? This would be nothing but pre dot next, right? So this is how we delete a node. So we just need to handle some cases. So if x equals to 1, so why we are explicitly handle this x equals to 1? Because let's say if x equals to 1, then we need to run a for loop for 1 minus 2, that is a minus 1, right? So this for loop will not work for this negative integers, because we are starting from I equals to 0, correct? So we need to handle for x equals to 1, we can just write head is equals to head dot next, and we can just say return head, right? Then for rest of the cases, what we need to do, we just need to, let's say, store a t pointer head, and we can just have a for loop starting from I equals to 0 to I less than x minus 2 I plus plus, correct? And we'll just t equals to t dot next, and we will have the reference node just previous to the node that is to be get deleted. For this 4 to be deleted, we have the reference of this 3, correct? So this temp will ensure that, and we can just see now we need to handle some more cases, right? So let's say that you are at the second last node, right? In this case 1, 3, and 4, this was to be deleted, and your temp will be residing here. So you are at the second last node, so you need to take care, you need to check that if temp.next.next is equals to null, right? You need to check if temp.next.next is equals to null. Then what you need to do is temp.next equals to null, right? You cannot just say here that temp.next is temp.next.next, right? Okay, great. Because why we cannot do here? Because here temp.next.next is nothing but null, right? And you will get a null pointer exception, correct? So that is why we are separately handling this, where you need to delete the last node, and your temp will be residing at the second last node, right? For all the test cases, we need to handle no such thing, and we will just say temp.next is nothing but temp.next.next, right? And after this for loop, we can just say return head, right? So that would be the pseudocode for this question. That would be the method one, that is getting the size of the list. So please try to code this approach, and then we can proceed it with the code. So what would be the time complexity? So we are getting the size of the list. So O of n would be here, and then again using traversal for x minus 2, it would be O of 2n. So ignoring the constant, it would be O of n, and space complexity would be O of 1 because we are not using any additional space, right? Let us look at the code, and then we can maybe optimize. We can do it in strictly O of n, but let us see that. Okay, so that's we have discussed in the dry run. The same thing I have mentioned in the code as well. So if head is null and x equals to 0, then definitely no need to do anything, just return null. And we are now finding the length of a given linked list, and we are checking if the particular node that is to be deleted is greater than the length of the linked list. Then again, we do not have to do anything, and just we have to return null, right? And for I already explained you that why we are handling x equals to 1, because x minus 2 will give you a negative number and you cannot iterate for that, right? And for rest of the cases, we are running a for loop for I equals to 0 to I less than x minus 2, and we are again handling specifically the case where we need to delete the last node. For rest of the cases, we can just write t dot next equals to t dot next dot next. So let us hit the submit button. While it is submitting, let us do the time constraint analysis as well. So it is 10 power 5. We are using 2n. So it will be 2 into 10 power 5, which is less than 10 power 8. So this solution should definitely get submitted. So let us wait for that, and then we can think of doing this approach in exactly of n. So attempt number mine is showing 6. So definitely I have solved this question in past. So definitely 2020 I have the submission grade. Okay, so can we do this in O of n, strictly O of n, not 2n, just O into O of 1 into n, let's say. So is it necessary to get the list size? Is it necessary? I would say it is not necessary, and you can convert your code while finding the length of the list itself, you can do this thing, right? So first of all, if x is equals to 1, then you just need to do head equals to head dot next, right? Correct? Right? And you just have to say return head, right? That would be your for x equals to 1. For rest of the cases, what we can do is that we can make let's say I equals to 0, and then we can start iterating for this. So while mm, let us make one more variable, that is temp is pointing to head. Let's say for 1 3 4, my temp is here, and I need to delete the x equals to 3, that is the last node. So I will check while temp is not equals to null, and what is the condition we mentioned in the for loop? So I should be less than equals to x minus 2, correct? And I will just iterate my temp is equals to temp dot next, correct? Okay, and simultaneously I need to do I plus plus as well. So for this particular test case, my temp will stop here. My temp will stop here, correct? Because we need the reference of the just previous node of the node that is to be deleted, correct? Okay, so now we need to handle two more things. Let me write it down. So let us assume. So for the first case would be that we have traversed till end or the last node, right? There would be this case. So for that, I am mentioning that if temp is equals to null, let's say, correct? Because we do not know what is the size of the size of the linked list here. So let's say for x equals to 5 was given, then definitely this temp would have uh, already traversed the entire linked list. So that is why I'm checking that if it have already reached the null, already reached the end is nothing but the null pointer, or it just stopped at the last pointer, right? At the last node. So that's also I need to check if or temp dot next is equals to null, right? In that case, I need to what I need to do. You cannot delete that node, right? Correct? Okay. What will be the other cases that you have reached to the second last node again that we handled in the above case, that you have reached here, that is the second last node, right? So you need to again write it explicitly that if temp dot next is equals to null, you are handling that your temp has reached to the second last node, and here you will just say temp dot next equals to null. Why we are handling this? Because if you do this temp.next equals to temp.next.next directly, then this thing for the second last node is actually pointing to null, and you will get a null pointer exception. But for rest of all the cases, you can just say that temp.next is equals to temp.next.next, and it will work. Correct? At last, you can just say return head. So don't mind my handwriting, guys. When I'm speaking, please write it on a pen and paper so that you can easily trace back to what I have said before. Correct? Okay, so that is it. Please pause this video here now. And what is the time complexity? It is strictly O of n. And what is the space complexity? It is strictly O of 1. The constraint is 10 power 5, which is less than 10 power 8. So definitely this code would successfully get submitted. Now please pause this video here, try to code this approach by yourself in the code editor, even though I've given you the entire pseudocode. But yes, try to do it yourself, and then we can proceed ahead with the second method, or let's say the first method itself. We have ignored, we have optimized the constants. Okay, so that is the method two, or you can say the optimization of method one. And I don't think a walkthrough is needed. We have done the same thing I explained you in the pseudocode. So yep, we have a while loop here, and then we have handled two cases. That is, we have traversed till end, or maybe beyond the linked list, right? Beyond the length of the given linked list, and we need to handle the second last node as well. For rest of the cases, we can directly like this, right? So the compilation has been passed successfully. Let us hit the submit button for this code, and then we can move to the C++ solution. So great, this solution has also been successfully accepted. Let us move back to the C++ code now. So that's the C++ code as well. The compilation has been run successfully. Let me just scroll it down for you guys. And I don't think a walkthrough is required here for this code as well. It's the same we have done in the dry run and in the Java as well. So few last thing that you can start and fork my DSA repository to get it with the source code, all this C++ and Java code. And yes, great. And yes, let us meet in the tomorrow streak of day 307 or 365 and the continuation of our next playlist. Till then, keep learning, keep growing. Bye bye, and take care, guys.